Hello, everyone. We are the FXCollaborative and Forest Consulting team. We're super excited to be part of this workshop. We also were very fortunate to have Tri-Pyramid join our team. We certainly wanted to express our gratitude to Boston Valley and to Matter Factory. We learned a lot along the way, and it was great to have this opportunity. And there we go. So we're not going to go through all the names, but these are our primary contributors. And then we also did want to thank UB and Carnegie Mellon for helping to organize and host the event. Been great.
Thanks, Ryan. So just a quick setup of what we wanted to do. It's like in our design practice, we've been really trying to explore the expressive materiality of our buildings and really reduce our collective addition as an industry on glass, really, and focus more on mass instead of glass, really as an attempt to increase the performance of our buildings in terms of their energy impact. And some examples of kind of the work that we've been exploring in terms of the materiality of things from metal to glass to, from metal to brick to some terracotta examples that we've done here in the area. So this pretty much sums up what we wanted to do. We wanted to take advantage of this workshop to take the craft and the history and the richness of the terracotta material and its ability to be both crafted and ornate with its ability to be a high performance system that gets standardized and industrialized. And how does the materiality and richness get informed by that and married with the high performance? So we wanted to explore this duality. On the one hand, the expressive materiality, how can we take a terracotta panel that sometimes can become very flat which I'm sure the Boston Valley people here will say that that's a good thing, and consistent, but we wanted to really dial up the expression of the clay itself and pair that with this notion of manipulating light and the ability that you see in a lot of modern terracotta interpretations to do solar control. But in this case, we wanted to see how we could take the material and use it to evolve and transform light. So that turned into permeable solids. Permeable solids really leverages that rich materiality and craft of terracotta and creates this tension between opaque and transparent, dark and light. You'll see there are these sculpted forms that are both apertures and reflectors, and that create a solar responsive terracotta cladding system. And that really advocates and create a design that is a more expressive solid surface in building design. Erica?
All right, so with these larger areas of interest in mind, we developed 5 guiding concepts to really help focus our design process. So first, we have this idea of dualities. We wanted to create a screen that was really two-sided and that could provide 2 kind of opposing experiences on either end. We also wanted to manipulate light. We wanted to be able to let light into a space, but really transform it from something that was a bit more direct and harsh to something that was more diffuse and soft. Solid to open, we wanted to be able to apply this to an exterior. So we thought it would be important to account for open, semi-open, and closed conditions and find a way to transform those and translate those in a really smooth, gradual way. Solar orientation, we thought the system should adapt to different light directions and different intensities. And finally, we wanted to be able to make something that was modular, easy to repeat, and really celebrated the kind of natural texture of terracotta, the richness, but also leverage the glaze to reflect light into a space. So when we started developing these modules, we thought of it as really a 2-part system. One where we'd have these apertures that would capture light on one end, and then these tubes that would really transform light and reflect them in on the other end. And we looked at the system in a number of different shapes and scales, always thinking, though, that when they would be aggregated, we could get an effect similar to this aspirational image, something that glows, something that feels soft, almost cloud-like in a space. So with that design intent in mind, we continued to look at different systems for aggregating, different ways to produce these modules. And we had this really important shift in our process around this moment, where we went from thinking about these modules as stacked extrusions that would be self-supporting to thinking about them as these hung ram pressed panels. So by detaching the structural system from the ceramic system, we were really able to tune these panels, make them lighter, make them thinner, and just kind of tune them so that they would be able to transmit light and transform light similar to our design intent. So with our final terracotta module, it was carefully crafted to respect the constraints of the ram press process. And at the same time, we wanted to be able to create these consistent and dense openings so that we could get, light into the space. We also thought about, the angle of the cones and how the light could be able to come in, bounce off the cone beneath, and then be reflected back into the space. So here it is in its aggregated form from the exterior. We use this hexagonal pattern around the cones. We think it's a really great way to hide the joints and make it so that you can't read the individual panels. So it was really important for us for this to feel like a field, a field of raw terracotta from the exterior. And then from the interior, that opposing effect. We have the soft, glazed, sculptural form with the glow of light by nature of the way the light is coming in, hitting the cones, and bouncing back out.
So once we figured out the effect that we wanted to test this in reality as sort of proof of concept. So we did a series of 3D prints. This one was a scaled model of a couple of modules ganged up to create a bit of a field. And we had it two-toned to try to imitate what would eventually become the natural terracotta and then the glazed side. And you can see that the light effect where the light is coming in from the cone above and hitting the tip of the cone below is happening. We also did a one-to-one study of a cone with some glaze samples below to really look at that spot where the glaze would be most illuminated and see how that angle really affects how we view that glaze. And we did some materiality studies on the natural side of the terracotta as well, the unglazed side. Again, we really wanted it to have depth. We didn't want it to be flat. We wanted it to be rich and really embrace the roughness. So we looked at adding different colors of grog, sawdust, different additives. And then for the glaze side, looking at glazes with different hints of color and runniness to really see which glaze would be the most illuminated on the cone side. And as we were refining our materials, we were also looking at a larger application of these panels on like a building scale or a pavilion. So looking at end conditions as well as bringing it back to one of the earlier concepts of an open to solid facade, parts of the building wanting to be more solid, some wanting to be more open. And so we developed a series of panels of the same series of panels based on the same module that would move from something very open and with deeper cones to something that was flatter and more dimpled but wasn't open, and carrying that hexagonal joint all the way across to allow it to read as a singular field, even though they're a series of modules. So you can see the cone shrinks and starts to become more shallow until the last two modules where it's totally closed. We also started thinking about the different kinds of light, diffuse, direct, and then the different amounts of light that are required for different programs. So a museum, an office, and a reading room wanting different amounts of light, and how that might be able to be achieved by flipping the orientation and the wire cut operation of the slice. So an undercut module allowing a lot less direct light in. And in this way, we're able to control amount of light, kind of light, and the view. And through a mix of those wire cutting operations and the fade, we're able to achieve a much softer, diffuse light that we can bring light into the facade without it being as harsh.
Thank you. So to develop the terracotta modules, when we made that distinction between ground-based and being hung, we had to develop a structure. So working with Forest Consulting and Tri-Pyramid, we developed a steel frame, a simple steel frame that's made out of 1x5 solid members. And this is important because it allowed the structure to sit vertically between the cones and also close enough on the image on the left. You can see that by having the steel close to the cones, it doesn't interfere with the lighting conditions that we were trying to achieve. And on the right, affectionately, what we call the bow tie is our connection piece between the steel and the terracotta. It's a natural concave shape that's developed out of the cones in the area and has 2 dead load anchors and 2 lateral anchors that hold the panel in position. So you can see from our install here, it's a fairly precise piece of engineering. Being an aluminum milled piece on a steel frame, it's naturally different from the terracotta process. We really wanted to embrace the handcraft. You can see on the left our ram pressed piece without the cuts, and on the right, a jig that Andy Brayman put together to actually cut out our cones. So the two are slightly different in nature. And when we assembled things, we learned that the challenges we thought we'd have were evident, but we were able to overcome them. We engineered some tolerances, and through some adjustments in the field, we managed to get to our final product, which we're really happy with. So this is the exterior view, the unfinished terracotta. Really happy with the way that the light models it from the exterior, the jointing and the flatness of that versus the duality of the interior, where, as has been described, the lighting coming through the apertures, bouncing off the reflectors, really illuminates that interior. Something a little bit unexpected was the play of shadow at the ground level. You can see that the tip of the cone cutting out to create that crescent shadow shape. And up close, you can really start to see the subtlety of the surface from horizontal to vertical and the thinness of the clay, which we really liked. And from the inside, you get a play of unfinished terracotta and the upper cones kind of peeking through. We've had a great time here at ACAW. We've learned a lot, and we really look forward to finding an application for this work. Thank you.